Welcome back to the channel. This is Anka Engineering and I'm Herman Wiegman. And today's video is going to be a tutorial on how to install a Quaife ATB unit into your Jaguar rear differential. Let's get into it. The focus of this video will be going over all of the procedures necessary to successfully install a Quaife unit into your differential. I first want to just go over some of the parts and pieces. Obviously the main focus is on the Quaife helical ATB automatic torque biasing unit. And this particular part number is QDF8W. Now, this was specially designed and specified for this application. All the details of this diff were settled upon, but the main reason is so that we can fit this to a large range of Jaguar models, from the F-Pace to the F-Type to the XF and XE cars. Okay, now you'll notice that Quaife carries other differentials for earlier Jaguars, but those were for different axle sizes. This axle for these cars is a 35mm shaft with 31 splines. And the earlier model Jags had different size axles with fewer splines. So this is for modern Jaguars. Now, to make this unit fit a broad range of Jaguar models, the deck height here of where the ring gear sits had to change. And so this deck height is set at a low level, and to raise it up to match the various gear ratios, we use spacer rings. And so the spacer ring can then help this unit fit multiple applications, okay? We also have special bolts. Because the spacer ring is there, these bolts are now longer than the original equipment. The rebuild kit will also come with axle bearing seals, which go on the unit here on the sides. And of course, the rebuild kit comes with new bearings. We also include some cups. And of course, there are spacer shims available in the kit, which are very important, which help set the bearing depth in the cover. And so these are important. Now, I did want to just take a moment and talk about vent options. On this particular unit, I just installed a rubber cap on there for safekeeping. The Jaguar F-Type models came with this very small yellow cap, and it was pretty useless. It did allow for some breathing, but also it broke and or it fell off. Now, the Jaguar F-Type doesn't have much room up in the crossmember area in the subframe. So other models, for example, the XE model came with this adapter, which is a rubber hose with a Gore vent on the end. Very nice. So it allows the system to breathe, but then no oil or moisture or water gets back into the unit. Another tool you'll need is a 55mm wrench. But this particular wrench for the Quaife unit, I also made it big enough to fit in a jack handle such that you can get the correct amount of torque on it to torque down the ring gear bolts. This particular one has the fill hole here on the left. This is the cover, and this is on the left-hand side of the car. And the fill hole here is typical for this unit, which is, again, open differential manual transmission car. The limited slip differentials, the fill hole is back here, and it's at a slightly different level than this one. And that's because the limited slip carriers were much more dense and had less open space. So when you filled it with oil, the oil went higher up the housing. And so this lower fill hole wasn't an appropriate place. You couldn't stick enough oil in, so they stuck the fill hole at a higher location such that you could get the appropriate amount of oil in the differential. So just keep an eye on that, okay? Here, around the pinion seal, as well as around the oil fill hole and around the cover. These three areas are critical. If they show evidence of oil leaking, it either means we have a bad pinion seal or a drain plug that's not closing well, or the RTV seal to the cover is broken. And that's bad because we don't want to lose oil from our differential. That would end up into an oil starvation situation, overheating and damage to the unit. The next step is to remove the ring gear and put it in a safe place. Holding the open differential, which has some features on it with the vise, so I can untorque these. The next step is to clean up the housing and the cover from all that RTV. And I use a razor blade and a steel metal brush. The next step in the process for me is if there's any doubt around the pinion seal leaking, I like to add some oil then and stand the unit up on its nose like this. So if there's 100 to 200 milliliters of oil here back behind the pinion, it will go down and go up against the seal. And then after 24 hours, you can inspect it and see if there's any oil coming out back behind the seal here, okay? The next step in the process is to mount these bearings onto the carrier. And I first clean them up with brake clean, make sure they have no more residual oil on them from shipping. And I also use Toast-O-Matic 300 over here to raise the temperature of the inner bearing to 300 degrees Fahrenheit so that it much more easily drops on the carrier. I did take apart an old bearing, use the center race, and we'll use that as a driver to bang on the bearing onto the carrier and get it seated all the way down. So it's always nice to have an old bearing around for that purpose. Now that the bearings have been applied to the carrier, we're going to try to set up the shims behind the races to set what's called the preload on the bearings. If the preload is too weak, the bearings are just floating around inside the case. If the bearing preload is too strong, you're squeezing the bearings too much and there's too much friction. So we're kind of get it just right. Now there's a trick to do this. What I'll do is I'll start with a 1.5 millimeter shim, which is about the target value, and I'll throw that in the housing. And we'll put the race in there as well. On the other side, on the cover, I'm going to overstuff this bearing and actually put in far too much. This is about 4.35 millimeters, which is more than 2 times target. But we'll throw those in there, apply the bearing. Now what's going to happen when we put the carrier inside and the cover on is that the overstuffed shims here is going to cause a gap between the cover and the housing. But we can use that to measure. It might be a millimeter or 2. We'll measure it in a few places around the circle, and then we'll take that off of the shims such that we then know exactly when the cover is going to land on the housing and start to squeeze the bearings. And that's our starting point. By the way, this trick of overstuffing a bearing was also contributed by Stephen Wadsworth, goes by Lizardo on the Jaguar forums. He built a lot of Saab differential units, and this helped to save some time. Okay, so this one is the overstuffed carrier bearing, and you can see the gap here. So I'm just going to measure that in a few places, and we'll see how much we have to take off. We can take a look at these shims and subtract off 3.2 millimeters, and that will get us pretty close to where we need to be. And then we'll do the final test by doing a pull test on the bearing preload. Now I added a shim to the cover here. I was at a comfortable level of approximately 6 inch-pounds of pull force, but then I added 0.2 millimeters or 8 mils of an inch more shim, and now it's very, very high. So I've gone beyond the point of appropriate preload, and now we're into crushing the bearing. So I have to take that shim back out again. Oh well, a bunch of back and forth, but once you get it right, you know. Now that we've set the bearing preload correctly, in this particular unit, it ended up being a 1.5 millimeter shim behind the cover, and also a 1.5 millimeter shim behind the housing races. And actually, those are actually my target values. So this unit is coming out to be right on average, 1.5 on either side. That still may change, because the next step now is to install the ring gear and get the ring gear to pinion backlash just correct. And so to do that, we may need to adjust the shims on either side, bias it one way or the other, so we get the backlash correct. This is the spacer ring. It does have a beveled edge, which goes towards the seat. And on top goes the ring gear. We also apply thread locker to the base of the ring gear bolts. I've mounted the carrier with ring gear onto one of my axle stubs, and I've placed it here in a vise just to locate it. You can also use a 1 1/4 or 1 3/8 inch dowel and hold that to mount your carrier to. This is the wrench, which is going to grab on to the carrier so that it doesn't twist, and then we can apply torque to these bolts. Okay, here we are, ready, set to 70 foot-pounds. First setting, now to 100. By the way, this does get a little sore on the ribs here, but it's a nice way to counterbalance the torque. I've placed the carrier with ring gear inside the housing. The housing shim back here is 1.5 millimeters, which is pretty much average for these rebuilt units. And I'm feeling now that there is some backlash, which is good. We can measure that. If there was no play whatsoever, I would have to take the carrier out and put a thicker shim down there. But this one settles in on the bearing, and there is backlash. That's a great place to start. Let's put the cover on and measure how much backlash there is. The first way to measure backlash is to do it off the pinion yoke. I've added a feature here, which is more or less a screw standing in one of the balancing holes. You can also apply a hose clamp and use the back of the hose clamp as a feature. Now this feature is a little over 2 inches away from the center of the pinion shaft, and so we have to take that into account. But this method sometimes is difficult because it's hard now to get just the backlash motion. And I'm just looking at the dial indicator, it's around 30 thousandths measured out here reflect it back to the interior, it's about half that much because the average pinion gear is 37 millimeters. So this method sometimes is a little bit hard. It's hard to get just the backlash. The second method is going to be on the axle stub. Measuring it here with a hose clamp around the axle stub, it's a lot easier to measure just the backlash. Now, this is only a distance of about 50 millimeters from the center of the axle shaft to my measurement point. But the backlash is actually occurring out here at about 100 millimeters radius. So in this situation, we have to multiply by 2 to get from the measured backlash to the actual backlash. And you will see here that this is having a pretty consistent 7 mils of backlash, but times 2 to measure it against the gear, it's around 14 mils. It's a little rich. I'd like to make that smaller. So there is a defined way of reducing the backlash by transferring shims from the housing side to the cover side. And I have a graph that shows what your measured backlash is versus your target and how much that shim should drop or be transferred from the housing side to the cover side. Now that the backlash has been appropriately set on this unit, we're then going to apply sealer underneath the cover. We apply an ultra gray gasket maker, which is for high torque and high vibration applications, specifically actually for this. So we'll apply that once taking the cover off one last time. There are some important steps here that need to be taken. First off, apply the RTV to the housing, not the cover. And I'll explain why. One will note that the cover does have a nice circular ring, and the assumption is that that seats against the ring of the housing. But in this region down here by the pinion gear, there are some cutouts. And I've shown on the cover here what that cutout looks like with my black Sharpie marker. So basically anything in this region is not going to squeeze out. The RTV has to be applied outside that dashed line in order to seal the housing. So it's much easier to simply take the RTV and run around the outside on the housing, not the cover. I made this mistake where I ran the RTV right by here and I thought it was going to be fine, but it never got squeezed out and I had a leak in the corner. So apply the RTV to the housing. Okay, here's the cover. This has been all cleaned. So this face has a 3 millimeter bead of the ultra gray RTV gasket maker for high torque applications. High torque, high vibration, which is exactly this. Okay, so I usually always hold the bearing race with my finger because otherwise sometimes it does slip out. This is a relatively loose fit. And then over she goes. And we want to apply the cover while the RTV is still wet. Okay, we don't want it to harden because it needs to spread out in the gap and be crushed by the cover housing interface. And then here we see some of the squeeze out. That's a good sign. And now we're ready to lightly torque the bolts and then go for final torque. Okay, now to properly torque the cover bolts down, I did put a stub shaft in the vise and set the vise at an angle so that I can get proper torque on those bolts. Now, these cover bolts are these M12 1.75 thread by 10.9 grade, and they do go up to 100 foot-pounds of maximum torque. We're only going to take them to 70 foot-pounds, but it's still very important that we get 70 foot-pounds on all of them. This cover actually sees a fair amount of force on it because of the pinion to ring gear interface. When you're laying down a lot of torque in first gear, there's actually a separation force caused by the angle of those beveled gears. And so this cover does see a significant expansion force as that ring gear wants to pop out of the pinion. So we have to get these guys well torqued. Now I've already done the initial torque, and now we're going to set it to 70 foot-pounds. Pound in our new oil seals. I like this particular brand, Febest, because they also come with the C-clips for the rear axle. All right, let's pop these buggers in there. I do find a 36mm socket kind of convenient to pound in the center. Okay, here's our tag. Punched it out. Tag number, date, serial number, gear ratio, and the recommended lubricant. Double-sided sticky tape, and on it goes. Well, that concludes today's video on the installation of a Quaife ATB into a rear differential for a modern Jaguar, particularly the i4 and V6 engine cars. Now, this was a long video, 20 minutes, so thanks for hanging to the end. But don't worry, not only have I documented through video, but also a set of directions on how to step-by-step inspect the unit, install the new Quaife, and get it ready for installation. And that's a separate document that's also available, is the removal and installation of the rear differential from your modern Jaguar. I just wanted to cover some of the highlights. This process wasn't too bad. It can be done with common tools, but some specialized tools are needed, like a dial indicator or the 55mm wrench to hold on to the Quaife unit while torquing bolts. Now, these tools aren't too expensive, less than $200. All the other bits and bobs that went into the unit, from the seals to the shims to the covers, that represents about $300 worth of parts. And of course, the Quaife unit itself is about $1,200. So all in, that's about $1,700, which is still much less than a new differential from Jaguar. You can get used units on eBay for roughly $200 to $600, but of course they're used and they don't offer the automatic torque biasing unit's advantages, which is maintenance-free, limited slip operation. I've also put links into the description that vector you to a library of videos that Anka Engineering has posted on YouTube. And it covers all aspects of removal or installation and limited slip versus Quaife ATB. So there's a lot of good videos there that you can look at and learn more about the options available to you. And I hope you've enjoyed this content, because I've had fun making it. And remember, my friends, drive well.